All right, we are back. In this question, each of the following APs, the first, second, and last terms are given. Okay, the first, second, and last terms are given. Find Roman figure 1, the common difference. Roman figure 2, the number of terms in each sequence. That is what we're going to find. So we have this sequence, and do not be confused. This ellipsis means that there are more terms here, okay? There are not just 3 terms here. So this is the last term. First term, second term, there are other terms here, then last term. First term, second term, last term. First term, second term, last term. This ellipsis means that, or 3 dots means that there are more terms there, okay? Solution. And like I said, the first thing we're going to do is to put down our data, right? The question says that we should find the common difference. And how do we find common difference? Common difference is a term minus its preceding term. Don't forget this. A term minus its preceding term. So the first one, A. The first term, A is equal to 1. Okay? Now, second term is 5. So my common difference is going to be equal to second term minus first term, which is equal to 4. You see, I have it. I have my first term and I have my common difference. So that's what the question says. Find the common difference. So we have it. I'm done with Roman figure 1. Then in Roman figure 2, I am going to find the number of terms in the sequence. And the number of terms in the sequence, I'll quote the formula, Roman figure 2. You have to write down the formula. The formula is Tn is equal to A plus n minus 1 in bracket times d, common difference. Which one is the number of terms? N here is the number of terms. N is the number of terms. And what is the nature of n? N is a whole number, positive whole number. It's not 0. N cannot be 0. N cannot be negative. N cannot be a fraction. It's a whole number, an integer. Okay? So n is an integer, a natural number, a counting number. 1, 2, 3. So if you are solving for n and you are getting a number other than an integer, a positive integer, then you're wrong. You're wrong. So let's fix it. Now, the last term. This one always stands for our last term if you're dealing with it, right? So if I fix the last term to be n, I will say let Tn be the last term, which is 69. Okay? If Tn is the last term, 69, my A is equal to 1 and the common difference is equal to 4, then I can find n. I'll only need to substitute, okay? In finding n, you go to the last term and fix the last term to be Tn, or fix Tn equal to the last term. Simple. And so I'm going to have 69 then is equal to, I hope you're watching, 69 is equal to, what's the first term? 1 plus n minus 1 bracket 4, which is the common difference. Okay, like this. If you like, you put a bracket, no problem. Okay, that is it. Now you can expand this bracket, open the bracket to give you this is equal to 1 plus 4n minus 4. 4n, sorry, 4n minus 4, right? So if you open the bracket, you have this. So all you need to do is to collect like terms. I will collect like terms now. Let me move every number down here, right? So I'm going to have 69, all the numbers without coefficient, the like terms. Let me move them here. Minus 1 plus 4 is equal to 4n. Okay, I'm finding n. And so 4n has to now be equal to 69 minus 1 is what? 68. 68 plus 4 is 72. So therefore, n is equal to, you dividing both sides by 4 now, 72 divided by 4. Okay, so you have n equal to 72 divided by 4. You see, 4 can go in 72 how many times? 4 can go in 7 how many times? 1. Remainder what? 3. Okay, 3. 4 goes in 32 8 times, so you have it. So the number of times is 18. That AP has 18 times. Let's go to the second one, B. B. In B, the AP is what? 98, 91, dot, 0. Okay. The last time is 0. So here, I'm solving for Roman figure 1, finding the common difference. A is equal to 98. D is the common difference. A term minus its preceding term. So this minus this, not this minus this. It's this one minus the preceding term. So it's equal to 91 minus 98. So D is equal to 91 minus 98 is minus 7. So you see it has a negative common difference. So now we're done with Roman figure 1. The common difference is minus 7. Roman figure 2. As usual, I will let Tn equal to the last term. The last term is 0. Have it. So therefore, I can have the formula 0 is equal to, using the formula, right? See the formula here. This is the formula. This. Okay, this one. The formula 0 is equal to A is 98 plus, in bracket, n minus 1, D is minus 7. So that's it. Okay, so I'll open the bracket to give me 0 is equal to 98 plus minus 98 minus 7n plus 7. So if I multiply n by minus 7, I get minus 7. If I multiply minus 1 by minus 7, I get plus 7. So that means that I can move this minus 7 down here to the left hand side to give me 7n is equal to 98 plus 7. 98 plus 7 is 105. Okay, so therefore n is equal to 105 divided by 7. Divide both sides by 7. So you're going to have n is equal to 7 goes in 10 once, remainder 3. 7 in 35 is 15. So that's it. Okay, I'll stop here. Okay, let me just solve the last one. The last one. The last one is minus 6 minus 2.5. Okay, see, we have minus 6 minus 2.5 dot then 71. Here A is equal to what? Minus 6. Common difference D is equal to a term minus its preceding term. This minus this, not this minus this, because this and this are not consecutive terms. Okay, so it's going to be minus 2.5 minus 6. You see, this is already negative, so it is carrying it, and there is a negative here. So D is equal to minus 2.5 plus 6. Minus is plus. Okay, so D is going to be equal to 6 minus 2.5 is 3.5. So the common difference is 3.5. I'm done with Roman figure 1. Then Roman figure 2. Number of terms. I'll fix this equal to the last term, equal to the nth term. So I'll say let Tn is equal to 71. That's in finding the number of terms. Okay, therefore I have 71 is equal to, the first term is minus 6, minus A, minus 6 plus, I'm using the formula, n minus 1, then common difference is 3.5. See, so that's it. So I'm going to manipulate this. So 71 is equal to minus 6 plus 3.5 times n. Okay, let me just make it an improper fraction first. 7/2, right? Improper fraction. So I'll open the bracket. 71 is equal to minus 6 plus 7n over 2 minus 7 over 2. Okay, let me collect like terms. Everything here, I'll leave this here and move everything to the other side. So 71 plus 6 plus 7.5 is equal to 7n over 2. So I have therefore 7n over 2 is going to be equal to 71 plus this is what? That's 77. 77 plus 7.5 would produce, that's 77 plus 3.5, 100, 77 plus 3.5 is going to be 80.5. 80.5. If you do it, so 80.5 should be changed to an improper fraction. 161 divided by 2, right? So therefore these two can cancel these two. 7n is equal to 161. See, so n is going to be 161 divided by 7. N is equal to, see, 7 goes in this 16 how many times? 2 times. Remainder 2. 7 in 21, this number of times is 27. Thank you.